Hi guys, welcome back to my channel. So in this video I'm gonna go over the topic independence of path. Okay, so in this topic we're mostly gonna find the work done, and every time we're asked to find the work done, you need to show that the vector field is conservative or not. Here in this question I was asked to find whether the vector field is conservative or not, but every time you're asked to find the work done in this topic, you're always gonna have to check whether the vector field is conservative or not. Otherwise you won't arrive at the correct answer. And also, to use the formula, first of all you need to show that the vector field is conservative, because when is the vector field conservative? When the curl of f is equals to 0. So first of all, to prove that the vector field is conservative, you need to show that the curl of f is equals to 0. And when you have proven that the curl of f is equals to 0, which means then we can use this formula of the work done, which is simply the dot product of the function dot product with the vector, the derivative of the vector function. And here the function, we can replace the function with the gradient of the function only if the curl of f is equals to 0. So the first step in here is to show that the curl of f is equals to 0. Okay, so I'm not gonna go ahead and show that the curl of f is equals to 0 in this problem, because I have already made a video on that. So if you want, I can show you. So here, if you guys want to know how did I find the curl of f is equals to 0, and how I prove that it's conservative or not for this specific problem, I have already solved it over here, and you can go ahead and watch this video. The link to this video will be shown here at the top in the I button, so you can click on it and watch it. And so once we have proven that the vector field is conservative by doing all this step, okay, so first of all we're going to do all this step and prove that the vector field is conservative. Next, what are we asked to do? So first we're asked to find conservative, and then it says find the potential function, then find the work done in moving the function from point A to B. Okay, so now what is our next job? Is to find the function. Okay, and here, like I said, when we have proven that the vector field is conservative, we can replace it with the gradient, right? So here, this function is no longer the function, this is the gradient. Okay, so we are using this formula. Okay, so if this is the gradient, if you have been following my calculus 3 playlist, you guys know how to find the gradient. So the gradient is basically f of x I hat plus f of y j hat plus f of z k hat, right? You guys might use a different notation, which is like partial derivative of f with respect to x, partial derivative of f with respect to y, and with respect to z, right? So yeah, these are exactly the same notation. It's just that I write it in a easier way so that it's easier to understand. But yeah, they're exactly the same notation. So yeah, so the first one is the derivative, partial derivative with respect to x, y, and z, right? So here, this is, if this is the gradient, which means the first thing in here is f of x, right? Yeah, and what is the second thing? So the second is f of y. And what about the third one? So the third one is f of z. So partial derivative with respect to x, partial derivative with respect to y, and partial derivative with respect to z. Okay, so now in order to find the function, right, this is the derivative of the function, the partial derivative of this function, right? And we need to get to the original function. So how do we undo the derivative? I hope you guys remember undoing the derivative. If you don't, so let me recall, we do the integral. Remember, we always integrate to undo the derivative. Okay, so let's take the integral of this function. Okay, we're going to take a piece. So we are taking f of x only. So we're integrating f of x, and it is 2x sine of y plus e to the 3z. Okay, let me use different color for f of y and f of z, so you guys don't confuse that I only took f of x, not f of y and z. Okay, so I took f of x, and now what are we doing over here? We are simply integrating it, and here since it is the partial derivative with respect to x, and so that means we are going to integrate it with respect to x as well, right? We're not going to integrate it with respect to another variable. It's gonna be x because it was x, right? Partial derivative with respect to x, so that's why we're integrating with respect to x. And since it was a partial derivative, this is gonna be partial integral as well, not simple integral, because there are more than one variables involved. So here, since we're integrating with respect to x, that means y and z are treated as a constant over here. Okay, so let's go ahead and do this over here. So this is 2x squared divided by 2, and 2 and 2 cancels out, of course, and then this is a constant is going to stay over there, and this is a constant as well, so we're just going to write an x in front. Okay, so we can remove this. Next, so this is going to be our original function, right? Yeah. But the original function, since we only took f of x, not f of y and z, so that means we're missing the component of y and z, right? This is not the exact the whole function, because we're still missing the y and z part. We only considered x part right now. So, and also remember, when we take the integral, we always have a plus c. So here you don't need to write the plus c. Instead, you need to take into consideration that you might have f of y and f of z, like the y and z component, right? So you're going to make the constant as, you can take any arbitrary variable. I'm going to take an h, g, or any variable that you want. You can take it as long as it doesn't belong in here. Okay, and you can do a y and z. So this is like a plus c over here, but this is a constant, which is indicating that after the function we can have a variable y and z, and we don't know what is it yet, but we're gonna have to find it. Okay, so this is almost the answer, but not the answer, the final answer, right? Because here we were asked to find the function, so this is the almost the final answer, but we still have to find one piece. Okay, so now here we need to find the piece of y first. Okay, so for that we already have f of y in here, right? So we already have the y piece over here, and we need to find it over here. But here we have the derivative of the y, not the original y, the partial derivative of f with respect to y. But here we have the original function, not the derivative. So how can we make sure that we can get to the original function of y as well? So what about we take the derivative of this one with respect to y as well, so and then we can make it equal to this one, and then we can see what are the components that we are missing. Okay, sounds complicated, right? But it's not that complicated, so let's try and do this. So f of y, so we're taking the derivative of this function with respect to y, which is same as f of y. Okay, so partial derivative means x and z are treated as constant. Okay, so this is a constant, and what is the derivative of sine x? Is cosine of y. Okay, cosine y, yeah, cosine y. Okay, plus, and this is a constant, so it's simply 0. So you write it or not, it doesn't matter. And here, this is a constant as well, but it won't be 0 because it does contain some variables over here. So we're going to make it like h prime of yz. Okay, instead of like making it equals to 0, you're going to take the derivative of this whole thing. Okay, so you're just going to write h prime of yz to indicate that it's the derivative of this one. Okay, so now once you have f of y, you have f of y over here as well. So we're just going to compare these out. So x squared cosine y plus h prime of y z is equals to x squared cosine y. Okay, x squared cosine y. So now we just compare them and see these two are equal, so you can simply cancel these out. Okay, so canceling this out, so what are we left for h prime of y then? We're left with 0. So here, but we don't want h prime of y. We want h in the function, not h prime. So how do we undo the derivative? I think at this point you guys know how to undo the derivative, right? So we take the integral of the function. Okay, so we're going to take the integral of this function. Okay, and we are looking for y and z components. So first let's take with respect to y. Okay, 0 with respect to y. And what is the integral? What is the integral of 0 with respect to y? Of course, that is gonna be 0 as well. Okay, but here, of course, don't forget the plus c over here. But again, you're not going to write it as plus c. You're going to write it as plus h of z. Okay, because here you already took for the y, you already took y into consideration. You drive it with integrated with respect to y, but you found out that it's 0. So you know the y component is 0. So now you don't know about the z. So now your job is gonna be to find the h of z. Okay, so here you guys just find out that h of y, y is equals to 0. Now you just have to find what is h of z in order to complete this function. Okay, so in order to find h of z, like we have to find the h prime of y z. To find y, we integrated with respect to y, right? And now we need to find z. So what are we going to do? We already have f of z over here, the z part. So we're going to integrate this function. Derive this function with respect to z, because we already have the partial derivative of f with respect to z. So now we're going to derive this function, take the partial derivative of this function with respect to z, and then make this equal and find that h of z. What does h of z gives us? Okay, so oops, sorry for that, I just clicked something. Okay, so where were we? So we were finding this function with respect to z. So if you want, let me do it over here so we have more space over here. And yeah, forgot to use green for f of y. Okay, doesn't matter. f of z. Okay, so what is f of z? Partial derivative of f with respect to z. I'm just writing two notations so you guys get familiar with the notation. I usually use this equation, this notation, so don't confuse with this one. Okay, these are exactly the same notation. Okay, so this one with respect to z, that means x and y are treated as constant. X and y are constants, that means 0. X is a constant over here, but we're deriving z, so 3z, and then multiply by the derivative of the inside function, so that's 3 plus, oh, I forgot the x, which is a constant. Okay, and then we have h prime of yz again. Okay. Okay, let's just say, because you know what, you guys already found that h of y is equals to 0, so I think you can only remove that h of y is equals to h of z, right? So why not just replace it? So we are only left with one variable. H of yz is equals to h of z. So okay, so let's just replace this in here and say that it's equals to h of z. Okay, so now we only have one variable, which is z. H prime of z. Okay, so now we have the f of z, and here we have f of z as well, and now make these two equations equal to each other. Okay, so I just wrote this equation. Now let's write this equation side by side, and what do we see? So this is going to cancel out. Oh wait, I just saw that I made a little bit mistake in writing the question, because in the original equation we had a plus 5 as well. When we find the curl of f, when I rewrote the equation, I completely forgot the plus 5. I'm sorry for that. So let me rewrite the plus 5 in here. Okay. So plus 5 here. And now these two cancel out. And what are we left with? For h prime of z now, we are left with 5. But here we want h of z, not h prime of z. So what do? We are going to integrate it, right? And what are we going to integrate it with respect to? We're going to integrate it with respect to z. There's only one variable involved, okay? That we haven't found, right? Because here we had 2 and we were looking for y first, so that's why we integrated with respect to y. Now we're finding for z, so differentiating with respect to z. So now, after the integration, we are left with 5, sorry, this has to be dz. Wrote the answer before deriving it. Sorry for that. Okay, so dz. So after the integral, we are left with d of z. Okay. And then if you want, you can write the plus c over here, but it's not mandatory, because after that you find the work, it's eventually going to cancel out. But if you want, you can write a plus c at the end over here. So then your final equation turns out to be, but yeah, this is not the final answer, this is the answer to the equation. We still have work to find. Okay, so that means this equation, I can write it over here. So the final equation turns out to be f of x, y, and z is equals to x squared of sine of y plus e to the 3z x plus, and f of y, remember it was equals to 0, so you don't write it, and h of y is equals to 0. So now h of z, which is founded as 5z. So this is the function that we were looking for. This is the answer to the function. Now we just have to find the work done by moving the particle from point A, which is 1, 0, 0, to point B, which is 2 pi over 2, 1. Okay, and for that we just need to do plug in into function point B minus point A, and the point A is equals to 1, 0, 0, and point B is equals to 2 pi over 2 and 1. Okay, so first of all, let's plug in B in this equation. So we have 2 square, which is 4, sine of pi over 2 plus e to the 3. I hope it's clear to you guys that the points, if it's not, let me rewrite it, because I wrote it in a rush, might not be clear. So it's 1, 0, 0, and b is equals to 2 pi over 2 and 1. And by the way, you don't need to write all these notes. I will provide the notes in the description below, so feel free to go over there and click on the notes to download them. Okay, so this is x, y, and z. So I'm only plugging in these points into this equation and finding my work done. Okay, so first let's plugging in this. Okay, so we are here. What is x? X is 1, so we're gonna leave it over here, and that is 1 as well. And then plus c, I forgot the plus c over here because we had plus c for each of c. I'm doing a lot of mistake this time. I don't know. C plus c. Okay, and then we're going to subtract it from f of a. And what is f of a? Just plug in these points into this equation. So 1, that's only 1, and then sine of 0, that's 0. You guys already know that. And plus e to the power of 3z, which is 0. E to the power of 0 is 1. And then plus 5, 0, that's only 0. And then plus c again. Okay. So this is, what is sine of pi over 2? Okay, sine of pi over 2 is 1. So this is 4 plus e to the power of 3 plus 5 plus c and minus. We only have 1 left over here. And then because this minus is going to multiply this whole thing, right? That's why I put brackets. So don't forget it's going to multiply. Okay, and we have minus c over here, so plus c and minus c are going to cancel out. That's why I said you guys that if you write plus c or not, it's not that important, but if you want, you can write it because it's eventually gonna be cut out in the work done. Okay, so what is your final answer then? So you have 9 and then 8, so you have 8 plus e to the power of 3, and that is your final answer. That's your work done. Thanks for watching and bye.